Good evening, everybody, and welcome to our seminar on MYP Science at West Island School. I'm really grateful that you could join us tonight. As we go on, Mr. Gilchrist will be talking to you about science and science at MYP in particular, and I'm sure that some of you will have some questions. There is a question and answer function at the bottom on your toolbar, so you can ask questions as we go along, but I would say maybe leave it for 10 to 15 minutes because you might find that your questions are answered as we go through the presentation, but we'll do our best to answer them, and those that we don't have time to answer today, they could be sent to you later on as the school is able to answer them. So science. Well, MYP is all about inquiry, obviously, but never more so, I think, than in a subject like science, whether it's an investigation into the ethical implications of scientific innovation, or it's just making the connection between science and the everyday life. And I'm delighted that tonight we've got Jon Gilchrist here to help talk you through all these important thoughts. Jon's been working at West Island School for 10 years now and 10 years as head of science, and so I can't think of a better placed person than Jon to help you. So Jon, would you like to join me?
Hi there, Helena.
Hello,
thanks
Jon.
very much.
How are you tonight? Okay?
Yeah, great, thank you. All good, yeah.
Okay. Right, well, without further ado, I'm looking forward to hearing all about science at MYP. So I will come back and join you after your presentation, Jon.
Okay, fantastic. Thanks very much. Right, well, I hope the technology doesn't let me down. Let's see if I can successfully share my screen and present. Now there'll be a bar in the way. Let me just hide my meeting panels. Okay, so the presentation today, as Helen has said, is about middle years programme science and the essential science skills that we're trying to get students to learn during that journey. Now, just to warn you, we're going to try something different. If you have a second device, phone, tablet, we're going to try a quiz, a science quiz, during the middle for a little bit of entertainment. A phone screen's absolutely fine. You don't have to. You can just watch what I'm presenting, and that's absolutely fine. But it might be good fun just to join in and see what our Year 7, 8, and 9s are learning during science. So let's just start off with some basic questions. Which some of you may be interested in about the MYP programme in general. Let me just click on. Okay, so standard questions we get asked a lot. Is there a fixed MYP syllabus? Some subjects like maths do have a specific syllabus that they have to deliver, but for science there isn't. It's very open. We do have, though, MYP science objectives. We have 4 that the MYP programme put forward called A, B, C, D. I'll be explaining a little bit more about that during this presentation. Do those objectives have fixed assessments that all MYP schools have to do? The answer to that is no. We're running MYP in years 7, 8, and 9. Some of you who know a little bit more about the MYP programme might know they're trying to bring in some assessments for our year 10s and 11s, fixed ones. But for our year 7, 8, and 9 MYP programme, the MYP course, which is run by the International Backup Organisation, the IBO, they don't have fixed assessments, so we can make up our own assessments. But is there a fixed method of assessment? Yes, there is. So the MYP say that we have to have a common marking grid that all schools have to use. So you may see some of these, we give them out to students, we call them rubrics. And we pass them out to students, and so they can see exactly how we're going to be assessing their work and what they need to show within those assessments to get the marks. It's marked out of 8, so that marking grid clearly shows what's the 7 and 8 piece of work, what's the 5 or 6 piece of work, and we pass those out. So they are produced by the MYP. Which leads to a difficult problem then, because that means for science, the MYP is very much a framework for learning. So schools within that can actually decide what we want to study and what units we want to deliver to cover those objectives. So when we started this journey for us as West Island School, what are we going to be doing with our year 7, 8, and 9? We had some key questions to ask, really. What do we want our students to be by the end of year 9? Now, obviously, for us at West Island, our students are going to be moving to the GCSE programme. So we know very clearly the kind of skills, the kind of curriculum content that we want our students to have learned during that MYP program. But in terms of skills, well, there's lots of skills, traditionally that students will learn. A lot of that will be practically based, inquiry based. So just little things like, do they need to know how to use a microscope? Do they need to know equipment they might use in investigations? Do they need to know how to measure? Definitely. What equipment would they need to do during an investigation? So these are kind of typical science skills that would expect Year 9 students going into Year 10 to be really good at and really confident with. But what do they actually need to know? And this is a really interesting one, because I get asked it quite a lot by parents. From when I was at school, I'm sure for many of you when you were at school, it was all about knowing stuff and learning facts and learning vocabulary. And that really has changed. And one of the reasons for that is the internet. Obviously, we can look things up. We don't need to rote learn pages and pages of information. So is that really something that we should be delivering to Year 7, 8 and 9? And there's a mix there, because there's some things definitely that students should have an idea about. So for things like, give an example, we discussed things like for Year 7 and 8 and 9 students, should they have a basic knowledge of things like the digestive system? Should they know a little bit about electricity? Should they know what some of the symbols are? Definitely, it's like the language of science. So there are things they should know that just form a good background general knowledge for science. Okay, but the key question then is, by the end of Year 9, we wanted to say, like, what would a really good scientist at the end of Year 9 look like? What skills should they have? What should they know already? And what should they be able to explain? So this is all about learning to be a scientist. In fact, it's one of our first MYP units we have in Year 7, is actually becoming a scientist, learning how to be a scientist, which obviously leads to the question, what is it a scientist actually does? And the MYP is very strong on this. There's a little quote in their MYP handbook, which is this: so the scientific mind does not so much provide the right answers as ask the right questions. And I think that gets to the nub of what Helena was talking about in the introduction, in that the MYP is an inquiry course, and it's students asking questions and then wanting to find out the answers. And that is great for our young students in school to be enthusiastic about science and coming up with really good questions, and then not doing the traditional thing again, which some of you may be used to when we were at school. You just tell them the answer. Okay, there's a good question, the answer is this. Is actually doing it slightly differently, saying, right, that's a really good question, how could we find out about that? And then setting up some practical work for them to do, setting up some inquiry tasks, so that students learn how to be a good scientist. Okay, so moving on, I just want to show you the 4 objectives that the MYP give us as part of that program. Now, those of you who are not too frazzled by working at home and looking after home learning might have noticed I've got A and D there, and B and C seem to be missing. I'll come back to that in a minute, because B and C go hand in hand, so they're on the next slide. But the 4 strands that MYP expect us to cover in our science program: A, knowing and understanding, which is very much scientific knowledge, and I think that's more, I was going to call it traditional science. It's just learning facts, learning knowledge and applying it on problems in exams. And so A, the strand A, is almost like traditional science that many would expect, but that's only now one in 4 parts of the MYP program. Whilst they're learning some of those key pieces of information they'll need to explain things, D is really important, that we're teaching students to gain a global understanding of, and it says there in bold there, scientific developments. And then when they're learning about those key scientific developments in the world, things like global warming, I'll talk about that a little bit later as one of our units. They also then need to be able to explain clearly what the problems are, and that's a bit of communication skills, and picking up that skill of not only understanding what the problem is, but be able to explain it with scientific language and have good communication skills to be able to do that. Okay, let me move on to the other 2. Now, this is the key one for MYP: inquiry. And inquiry is is very much practically based for science, obviously. So objective B is the MYP and us at West Island would like our students to develop practical skills. So they come up with a question, and I'll run you through an example shortly. They come up with a question, or we direct them to something. They then think it through and they go, actually, I would like to find out about this. And then they have to be able to design their own experiment to do that, think through how it's going to work, and then obviously perform that investigation. And maybe during performing, they realize it's actually not going to work and they need to go back and modify their plan. And then objective C then is actually doing their plan, collecting evidence, processing it, and explaining their conclusions. So things like results tables, graphs, writing conclusion, and then it says at the end they're evaluating the method. A lot of our students find that really hard. They've sort of at the stage, and I know I feel very comfortable with this. I've done the experiment, it worked. I've shown a graph, I've finished. I really don't want to then write a paragraph saying, if I could have gone back and done it again, I would change this. And that's a really tough skill. And it goes all the way through our program at West Island, right up to year 13. The skill of actually being able to go back and saying, well, we found this out, but actually thinking back, was it solid evidence, or was our experiment a bit flawed? And then being able to evaluate that process. So that's called objective C. So you might have seen, if you've got students in year 7, 8, and 9, that we're then assessing them on these tasks. So it might be called an assessment B, and they've got a plan and investigation. Or we might be giving them a task that's an assessment C, where we're looking at their interpreting the data, drawing some graphs, deciding what graphs to draw, those skills. Okay, so moving on. So let's put that in context at West Island. So we might be doing a unit, let's say, about energy. And we would want some sort of inquiry science about the topic of energy. So we might be discussing with the class about what types of energy are there, and students will be learning about kinetic energy. They'll be learning about potential energy, chemical energy. So in that inquiry, we might be talking about tennis balls having a lot of kinetic energy. And one of the students is talking about playing tennis and saying, well, when I hit the ball, it goes really fast, it has a lot of kinetic energy, hits the ground, bounces, 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 and then it stops. Where's all that energy gone? And that's something we could explore. And one of the students might say something like, well, I've noticed in the summer, the ball is bouncing higher. Okay, and then straight away you're in, okay, that's an interesting question. Now, you could just tell them the answer of why that happens. But what we're trying to do then is use questions like that as a framework for an investigation. So then we'll be going into, with the students, that scientific method. How do we find out whether that's true? Is the temperature, though, in the summer, it's a lot hotter, is it affecting how balls bounce? That's a great question. What can we do to find that out? And then the students will come up with some sort of, okay, maybe I could do this, maybe I could do that. And then we'll ask them questions like, how can you make that a fair test? How will you know that the data you're getting from your experiment is actually giving you an answer? And we think that's an MYP. This is the key thing in the MYP science course, I think, is that getting students to think about how science is done. How do we know this information? How do we know certain things about, say, global warming, certain things about the virus? I'm sure lots of you have had those discussions where, oh no, it's like this. Oh, how do they know that? How do they know that works? And it's that, okay, it's been checked, it's been researched, there's lots of evidence there. Scientists have evaluated that evidence, and most agree that that is a solid piece of evidence. So it's that scientific method right early on in year 7, 8, and 9, we're trying to get our students to think through. So they would then come up with a plan and try and think, how am I going to do it carefully? And then while they're doing that, then you've got that concepts and language. So again, kinetic energy. Let's have a little, sorry, go back a little bit. What are the things? Concepts, kinetic energy, elasticity. They might have something about the air inside the ball. Someone might say, maybe it's something to do with the air inside the ball getting hot, and that changes how much it bounces. So then they will draw in what they've learned in the science units, and then trying to explain those concepts. So those are the sort of key skills that we're expecting our students to develop over the course of year 7, 8 and 9. Yes, they have good concepts, good understanding of some science ideas. They can explain it using good language, but they know how science works. They know what the scientific process is, called the scientific method, and they know how to carry that out and do investigations all the way through. So yeah, if you've got students doing in 7, 8 and 9 at West Island, I'm sure you've come across them talking about, I've got an A assessment, B, C, D. I've got to design a plan for this investigation. I've got to then do some results tables. And it's a key part of what we want our students to finish year 9 with, key skills that they can do. And in fact, for GCSE, it's now 20% of the GCSE course is basically talking through that scientific process, and they have exam questions on each paper talking through how an experiment was performed, maybe plotting a graph, key skills doing graphing, writing a conclusion, evaluating a method, and that is part of the GCSE. So it is definitely something we want our students to learn. Which brings me promptly, how are we doing for time, to time for a little quiz. Now, if you've got a phone handy, I'm just going to switch over and we're going to do a little audience participation quiz that is going to be based on that sort of method of teaching and learning during our MYP program. Now we're going to go T mode. If some of you are watching this together, sorry, I need to stop share. I need to check that I have the sound fixed on. Yes, I have. Right. Okay, let's do that again. Share. Okay. So what's going to happen, let me just explain if you've never done a Kahoot, is you go to kahoot.it and you put in that game pin. So you should be able to see a spot to put in the game. But now, if you just want to watch, that's absolutely fine. It might be nice if some people who are in the presentation just for a little bit of fun to join in. And give about a minute for people to type in emails. Now, obviously, we have some very competitive parents out there. That's great. If you want to do it as if you were a year 7 student and on purpose get lots wrong, that is absolutely great. If you want to go anonymous, that is also fine. Okay, I'll give another 30 seconds or so. The reason I'm showing you this is just to show the kind of the difference really between what some might again see as the traditional science course and the kind of thing we're getting our year 7 to 8 to do, 22 to 24. Okay, I'm going up really quick. That's why I'll just give a few seconds to stabilise this. Okay. Going up. We have done this quiz, or I think most of the questions on this quiz with our year 8. Yeah, I think. Okay, 10 seconds, and then we'll start. Okay, right, we're going to start now. Here we go. Okay, so this is all about the scientific method and experiments on rusting. Here we go. So if you've not done a Kahoot before, click the right coloured button. You've got a few seconds team talk. Is it frozen? Just exit full screen. Okay, my screen seems to have frozen. I'm not sure if anyone else is.
Mine's the same, Mr. Gilchrist. It's just going round and round. I'm trying to prove what a brilliant scientist I am, but I'm having a problem.
Yeah, okay. I'm worried about pressing refresh halfway through the quiz and whether it'll. What do you reckon? Do you reckon I press refresh the page? It's frozen on Team Talk. You've got 4 seconds Team Talk, and then yeah, I'm not sure. Oh, maybe we could come back to it and try it again in a minute.
Why don't we try it again? I think you're like Jennifer Aniston. You've broken Kahoot. Like
I think so. I might just quickly press the refresh. Let's see if it manages to refresh that question. Let's see if it messes up, reloads the site. I just don't want it to do a new team code. It might do. No. Should we try one more time? What do you think, Miss Murchie? Should we?
Yeah, I've been given a offer to reconnect. I'm just reconnecting. It says retrying in 1 second.
It might give us a new game pin though, I think.
Yeah.
Let's give it. Should we give it one more go? Do you think? New game pin. How frustrating.
Okay.
Okay, that was a practice run. Should we just try? We'll give it one more minute and then last go, and then we'll try it. Sorry, everybody. I'm not sure why it froze there. So we had a practice at putting names in. Great. It might just be the volume of the graphic. Okay, that's fine. If this doesn't work, I can just pull the quiz up and talk you through some of the. I think we had 45 times. Oh, we've got more teams this time. Okay, we're there. Right, cross fingers. Let's see if it works. 10, 9, 8, 7, 6. 5, 4, 3, 2, 1. Okay, here we go. Let's start it and see if it works and doesn't freeze. Come on, computer. Okay. Okay, time is ticking. Good. Okay, seems to be working. Seconds to answer. 5 seconds. Okay, there we go. All 42 correct answers. Very good. Okay, on we go. Next question. Now, the reason Cooper in the front is they did the fastest answer, so it's also on speed if you've not played one of these before. Okay, here we go. It looks like it's locked on 6. Right, I'm just going to press the skip button. Otherwise, we're just going to be here forever. Let's see if we got to the. We got enough answers. We played Kahoots like this with whole year groups before, so I know that it works with large amounts. It won't let me skip now.
Mr. Gilchrist, I'm desperate to know if I'm right or not.
I know. I really want it to move on. I know I can't press refresh now. How frustrating. Okay, I'm pressing skip. Nothing's happening. Okay. All right. I think, Miss Murchie, shall we? I'll just pop to the screen. I think I'll just have to show the questions. Okay.
I think sadly you're just going to have to share it with us.
Yeah. Okay. All right. It's a shame. It would have been nice to play it as a proper quiz. I'm just going to have to quickly show the kind of questions. So I'll just show you on the build mode. Can you, Miss Murchie, can you still see my screen? It's just loading a.
Yes, it's just loading.
Okay, fine. The reason I wanted to show you this quiz, just while it's loading, is pretty much the only bit of scientific content in this quiz was the very first question. All of the rest of the questions on it are about doing science, the scientific method. I think this is probably why Kahoot isn't loading, because it seems to just be going round and round. I'm not getting very far at all on this. Let's just try it 1 second. Okay. So a lot of the questions are based on how science is done. So writing a research question for an investigation, deciding which one are the variables that we need to keep it the same to make a fair test. Okay. Oh, that's taken a long time to load. Right. Free mode. Here we go. Let me just quickly see if I can show you some of these questions. Okay, here we are. Okay, that was the one. If you put mass increase, you were correct. Okay, now I'm just going to skip down here to the kind of questions we're giving our students. So let's see if I can preview mode. Okay, this question, I want to see how the temperature of water affects the nail rusting over a 2-day period, which would be the dependent variable. Okay, and so we're asking students to understand the difference between a dependent variable and an independent variable. So in that case, the mass of extra rust added on the nail would depend, so it's the dependent variable, which would be the independent, would be the temperature. And then trying to come up with a research question. So this is one of the things the students find really difficult. So which way around would it be? Should be, how does the temperature affect the mass of rust on a nail, rather than the other way around? How does the mass of nail affect the temperature? And it's these kind of skills that students find really, really difficult. Okay, I'm going to go back to the presentation, which is a real shame that that didn't work properly. So apologies for that. It's just obviously a little bit lag on that. Okay, now I'm a bit conscious of time. Now, very quickly, let me just talk through this because I do need to finish in a minute. So examples of an MYP unit. So one of the units I talked about earlier, we do a unit on global warming, and each unit has got a statement of inquiry, which just underlines the whole unit. So clearly this is to do with the relationship with the humans and the environment. The key words there in pink and blue are the words that are key skills that are transferable between different subjects. So obviously the relationship between humans and the environment, the relationship, that isn't necessarily something only to do with science. So it's getting students to understand the connections between different subject areas. What might we cover within that? I'll just whiz through this. We might cover about heat transfer, which is physics. We might talk about carbon dioxide and the carbon cycle, which is a bit of chemistry. We might talk about human impact, burning fossil fuels, and then the effect of warming and acidification on ecosystems, which is a bit of biology. So that unit is very much across the 3 sciences. And we have some questions that go along with that unit that we expect students to be able to look at, and they lead our lessons. So why is it that students are expecting the world to warm? Why is everyone talking about it? Global issues, and what effect does warming have on the sea? And then some harder questions, some conceptual ones that are quite difficult to explain, and then some debatable questions as well. And in that unit, just to give you a flavour of the kind of assessments they do, that unit has a B assessment on planning and a C assessment on carrying out the investigation and showing their results. And there's an image there, a picture of a little baby temperature scanner. So we gave them that as a sort of piece of equipment that could help them to plan this investigation. And it was framed about whether, when ice is on the Arctic and Antarctic, and that ice is reflecting heat back into space, what if it melts? What if there's now black rock underneath? Does the color of the surface change how the Earth absorbs heat radiation? So putting different colored objects out in the sun, and then using one of those little baby scanners to actually see whether one's getting hotter or colder, and then plan an investigation. Now, what do you think might have changed that? Obviously, color would affect it. Are there anything else that might affect how hot an object gets out in the sun? So that's the kind of investigation they were doing. That was a previous investigation. Now, very quickly, so the key skills for GCSE, what do we want our students to have by the end of year 9, just to wrap up? We want them to be knowledgeable. That's the A criteria, the A objective for MYP. We do need them to know some science information so they can explain things using science terminology, definitely, and some good vocabulary. But we want them to be inquirers. We want them to be able to go, okay, that's interesting. How would I go about finding out that? What experiment could I do to test that? And then we want them to think it through. We want them to be able to show what they found out. I thought, well, that tells me that this happened, and also evaluate it carefully. And we want them to be good communicators, which is all part of that process. So having that idea and explaining it, and explaining it clearly, using that science vocabulary that they've learned, and clearly explaining their ideas. And again, I do like having some concrete examples. So just some examples of student work. So going back to that tennis ball experiment, for a beginner student in year 7, we might get a hot ball bounces high. This is because of the air. Very simple statement, not very clear. And what we're aiming for, going from that to, by the end of year 9, something like that. And I won't read it out, you can read it yourself, but it's just so much higher standard. The language is excellent. They're using scientific terminology. They clearly understand some difficult concepts about particles, modeling a gas with particles, compressing, pressure, elasticity, and then relating that to a different example, like for basketball. Okay, so that's covering all the strands. They've got good science knowledge, they've done the inquiry, they can explain it, they thought it through, and they've got great communication skills. Okay, so that's the end of my presentation. I'm going to stop sharing, and over to you, Miss Murchie. It's such a shame the quiz didn't work. I'm so gutted.
You know, but I'm a little bit miffed actually, because I thought that my first answer was answered extremely quickly, and I didn't even make it to 4th place.
I know.
So somebody out there tonight is a real Kahoot demon.
I'm wondering if we could get our IT tech, Mr. VJ, to maybe send a link out, because there is a way of doing that in your own time. So if we could send the link out, maybe
I think that would be. I'd like to know
sorry it didn't work.
I'd like to know who's the winner there. Thank you, John. Absolutely great presentation, and fascinating to me as a parent as well of a child that's going to start MYP next year. So thank you for that. A question that's come through, and this question's been asked a couple of times, John, is does MYP equip the students with the skills that they need to start the GCSE separate science courses?
Yeah, absolutely. And that is a question that I know a lot of parents have got concerns over, just because if the students are doing so much where they go, okay, great, I want to find out about that, are they actually missing out on that scientific knowledge and understanding that they need? And at West Island, we are a science school. We have some awesome science IB students. We have a lot of students taking high level, some taking 2 high level subjects, and we've got some great scientists. So we need to make sure that program prepares them for that sort of high level work, and definitely it does. We're keeping in the concepts, the key understanding, as I said, some of those things where they just need to know it, like chemistry is a language. If you're talking about water, H2O, they need to know what the H is and the O is. So we have to teach that still, and we do have to go through quite some detailed chemistry so that they can do those inquiries.
And I've just had another question come through around the assessment, just asking again, how do you assess students? So can you actually explain how it might be done, John? Is it through a written test? Is it through an experiment? Is it through a combination of investigation? What typically would it be? What would it look like for a student?
Okay, so because A is knowledge-based, very often that would be a paper-based assessment. So for instance, there's a unit in year 9 on Antarctica, and then to show understanding of their Arctic expedition, they might need to explain about what food they take and the carbohydrates and fats and protein, but they'll have written questions about that. For the B and C assessments, because they're practically based, they have to do an experiment, physically do it. But then obviously we're looking for the written report. We're looking for that written up.
Yeah.
So we're looking for,
theory.
yeah, that they've written down, okay, I did this experiment with a tennis ball. I was going to change the temperature of the ball. I was going to keep this the same. And then this is the apparatus I needed. Did you remember that you needed a ruler? And then those sorts of little things like in their plan, but it's a written plan. And then same for the C, we're going to be looking at the results, looking for a clear conclusion. What have they found out? Maybe some graph work. And then the D, because that's communicating science and the global issues, very often that takes the form of a presentation. Some of our students, we've left it quite open with some classes, where some students have done like a Google slide, some people have made a video. So any form of presentation where they can show their understanding.
That's fantastic, thank you. And a question that I've just read is there much overlap between what they're learning in MYP and what they're learning in GCSE?
Yes, definitely. So because we're wanting to prepare them for the GCSE courses as well, so much of a traditional year 7, 8 and 9 course would have covered those concepts like digestion, like circuits. And actually a lot of that is in the GCSE. So I mentioned about kinetic energy. Kinetic energy is a GCSE curriculum statement. So a lot of those things they will, and particularly in year 9, feed into the GCSE curriculum perfectly.
Got my mute on there.
Okay.
Thank you, John.
No,
and here's a question for you. So for parents out there watching, and it might be that their children are in year 7 and they have younger children, you know, what's the best way to encourage your child to become interested in science?
That's a great question. Yeah, I think it's that thing where with my kids, when they're growing up, so they asking you, okay, why is that? And then and you do fall into the trap of just wanting to explain. But it's just if they are interested in it, they want to find out more themselves. So it's that sort of thing where you go, okay, well that's interesting, or like global warming, you know, or why is everyone worried about it? Okay, well they could find out more about it. You could give them questions that they could go and find out themselves, and that's what sort of the inquiry process is all about, which I really like. So rather than just saying it's that, they won't remember that. What they'll remember a lot better is going away and finding it out for themselves.
Absolutely, yeah. Don't give them the answer, make them go and find out. John, thank you so much. That's been a wonderful presentation. For the questions that we haven't had time to answer, we will get back to you with an answer this week. Thank you for asking them. And I'd just like to say a big thank you for supporting us tonight. And your science is definitely, your children's science is definitely in safe hands. So we look forward to you hearing more about science from your children. Ask them about what they've been doing in the class, and hopefully they'll be able to tell you all about it. So thanks very much, everybody, and thanks for being with us tonight. Thank you, John.
Thank you.